Hello, I'm Justin Ross with Fluke Biomedical. One of my jobs at Fluke is being a sales rep, and I've been going around talking with hospitals about our brand new infusion pump analyzer, the Fluke Biomedical IDA-6. And some of the questions I get asked by customers when we first go in is, well, why do I need this big fancy infusion pump analyzer when I can use these scale and beakers and a pressure meter? And it's a really good question, and we want to go through some of those reasons today and show you that a little bit more in depth about why you really want to consider an infusion pump analyzer, especially one like IDA-6 that has such high resolution. So I have two different scales here on my desk. This one scale I borrowed from a hospital biomed shop, and this is another scale I had in my house, in my shop, for doing a hobby of mine. So I want to turn these both on and show you a few things. While they're turning on, here we go. You can see on this scale, while I'm reading in grams, it only has one decimal point, 0.0 grams. And again, this is a scale from a hospital that they were using for doing calibrations. This scale is my hobby scale, and you'll notice it reads to 2 decimal points. So 0.00 grams, so hundredths of a decimal point. So I want to do this neat little experiment. I have this syringe. You may have seen this syringe in previous videos. It only holds 50 microliters, which is a very, very small amount. And what I want to do with this is I want to get about 1 droplet of water out of it. So here it is. Here's the entire volume that I'm going to push out, 1 droplet of water. So let's do it again. All right. So 1 droplet of water, 25 milliliters, there we go. So I'm going to put that 1 droplet of water on this scale. And you notice that my reading didn't change. It still reads 0.0. All right, well, maybe that droplet of water is finer than 1/10 of a gram. All right, so let's try it again. We will go over here and take this down to 25 milliliters. And people ask, well, how important is 1 droplet of water or solution? Well, if you're pushing meds, that could make a big difference for some people. So let's try this 1 droplet again. There we go. And you can't read it. The camera angle is really bad. It still says 0.00. Well, now I'm kind of really confused when I was working with this. So let me show you one more time. This same 25 microliters of solution. Here we go. And I'm going to go to the IDA-6 and into manual mode, and we're going to measure that same 25 microliters of solution. So here we go, and we're going to push play. And it says it's waiting for the flow now. Now, as soon as I start to administer this, we had a pickup. We're reading 29 microliters or 29 micrograms of solution. So it's 0.02, 0.03 if you round up. And the scale should have picked it up, but it didn't pick it up. So that calls a few things into question for me. Is, well, does your scale have enough resolution for the job you're doing? And reading through a lot of the service manuals for infusion pumps, a lot of them are requiring at least 1/100th, so at least this scale. And while the scale should have worked, I give you, it's not a medical grade scale, it's a hobby scale, it wasn't fine enough to pick up or sensitive enough to pick up that 1 droplet of water. But my infusion pump analyzer definitely did pick it up. So again, if we're pushing certain medications, that 1 droplet of water could mean a lot when it comes to administering meds to a patient. A lot more accurate, a lot more fine resolution. All right, so let's move on with this, and let's talk more about what else we'd have to do if we're testing with the scale in a beaker. Well, here is a graduated cylinder. I see a lot of technicians using this as a collection device, and I have some techs who say that they can just use this graduated cylinder as their measuring device. And true, it reads in milliliters. This one reads 25 milliliters. A lot of infusion pump tests are pushing about 20 or 30 milliliters out, so theoretically this would be a good scale. But if you look at it, each of these lines is 1 milliliter. That little line is 1/2 milliliter, so 0.5. So if you fill this up or you put fluid in it, you have to read, and you have to measure the bottom of the dip when it goes into there. And to do that, it has to be sitting down perfectly level on a table, which means you have to get your head down there perfectly level and read it. I just put it on here, and now I'm reading 68.2 grams. So I have to remember to zero out my scale. All right, so I zero out my scale. Well, now if I put my IV tubing on here, my IV tubing has mass, and now I'm reading another 10.5, so I have to zero it out again. So if I did my test and flow the water in, and then did I remember to take this in or out? How did I start the test with the in, or did I start it with it out? And that's going to throw off my weight. Oh, and even there, look at that, just taking it back out. Now I'm reading 0.4. So there's something about the sensitivity of this scale. And then if that last drop, did it count or not? Well, the other thing I don't like is this one's got a really small hole. I got another one. Hold on. Here's another beaker that I borrowed. So we could put this beaker on, and it's a different mass, so I'd have to tear this one out. And here's something I see some techs do to not have to deal with this hose in and out all the time, is they'll just take a block and this is a device for soldering wires to hold them together for you. So you could put it something like that and hold it above it, and now you run your infusion pump and push the fluid in, and when you're done, it'll collect in this canister and you get your weight, as long as you have fine enough resolution. And then when you're done, you would measure that and then dump it back out into a collection canister and put it back on here. And then before you start your next test, you have to remember to do the priming sequence if your infusion pump calls for it. Once the priming sequence is done, hit tear again to zero it out, do the test, but you have to be here while it's running. When that infusion pump completes, it's going to beep at you, and you need to be here because flow is a volume over time. So if your infusion pump stops exactly at the end of that test, you might be okay, but most infusion pumps have a KVO, keep vein open. So if I got distracted, say my phone rang, or somebody walked into the biomed shop and asked a question, or I had an email pop up that I had to take care of, and this used to happen to me a lot when I was a field tech, I would get distracted and not catch the end of the test. And then I had to guess, well, how long did it sit there from the time it beeped to I read it? Is there's a little bit of KVO enough to throw off my measurements or not? But it calls a lot of things into question and can add some uncertainty to your tests. So, and then I had to dump it back out and start over again, and I'd always end up repeating 2 or 3 tests a day because I got distracted, and that's more time on a good day, 2 or 3. Some days the phone rang a lot. So again, you have to be here, you have to catch it, you have to make sure your scale has the right resolution, you have to make sure that your scale is sensitive. I forgot to mention something about these scales. This scale doesn't have it. Now this scale did it. This scale, if I take it and I turn it, it will say it's unsure. You see UNSR. That means I have to make sure the scale is perfectly level. Same with these scales. A lot of them will have a level bubble and some feet on them for the higher accuracy ones, and you have to make sure that scale is perfectly level, which means you really shouldn't be moving these things. So that's another little bit of a challenge that we'll talk about more here in the future. All right, so that's how we do our flow and our total volume tests with this method. And then we'd have to do some occlusion tests. There's an upstream occlusion test where you just pinch a hose, and then a downstream where you need to use a pressure meter. So this is my pressure meter. This is one I used to carry as a field tech, and I would turn it to either millimeters of mercury or PSI, depending on what my service manual calls for. And you're going to notice I just turned it on, and I zeroed this out yesterday, and today I'm reading -3. So the first thing I need to do is I need to zero that back out here. Put me too far. There we go, 0.0. You have to make sure that your pressure meter is zeroed out. And again, you need to make sure that your pressure meter has enough resolution by your OEM's manual. So then, I'm done with my flow test. I take my pressure, I take my tubing off here, connect it to my pressure meter, like so. All right, now I introduce pressure, so I have to turn this stopcock ball valve until I read atmospheric pressure, and in which case I would do my priming sequence, and I need to hold this over a container like this, and it would prime in and the drops would come out, and then when I'm ready, turn this valve. And it's going to build up pressure here, and I would read that max pressure. But again, I need to be here and paying attention when my infusion pump alarms to get the peak pressure, because some infusion pumps will start to back that pressure off, and I won't actually catch the peak. I'll catch something after the peak. And again, how far after? So will your pressure meter catch the peak pressure? Or do you have to be sitting there and paying attention? And I'm telling you, the human error thing really starts taking effect when you have 2 or 3 possibilities of human error here and a few possibilities of human error here. All right, so now when I'm done with that testing, I need to take this back over my collection canister, and I would open this valve, and it would go and shoot some water out because it had built-up pressure into the collection canister. I see a lot of biomeds, and I hear you. This gets messy when you're trying to shoot stuff into it. So a lot of technicians will take some more tubing and a few extra stopcocks, and they'll build a system of tubing around their bench. So this can just sit here, and then they'll open the valve and push the pressure into here, and then change the valve over, and change another valve over, and change another valve over, and that same infusion pump test tube will push the fluid back into the cylinder. Then they'll change the valves around and push more fluid back into for the pressure test. And while people don't like to admit it, if you ask them to run a few tests for them, you'll see somebody will mess up and they'll turn the valve at the wrong time and have to redo the test. That happens a lot. So again, now you're losing tests, and that's also really quarrelsome. And I want to talk about one more thing here with that, and it's this infusion pump tubing. If you read some of the service manuals call that you use 2 sets of tubing. They will have a calibrated tubing set for your flow tests. So it'll have a piece of paper on it, and it'll have some correction factors, and you'll type that into the software that you're going to calibrate the IV pump with. And then you only use this for flow tests, and you can only use it for so many tests. I don't remember what it is, 20 or so tests, and then you're supposed to change out this tubing. When it comes for your pressure tests, you have to use a different set of tubing, because if you pressurize your calibrated test, it's going to stretch out this tubing and change the memory on it, and it might change that rate. So you need to use 2 different sets of tubing. So if you do that now, you need to have a second bag up here. And let's talk about these bags, because you'll notice this bag has a big hole in it. And that's because when I set this up today, I had to go get another thing of test solution and dump it into it, and it's not nearly as full as it was when I wanted to do this video, because in my traditional fashion, I went to move this and set up a second set off my IV pole like this, and I squished this bag and I shot water all over this bench, which is why I have my other piece of test equipment here, my calibrated mop towel, and I had to mop up the bench. So if you're 2 things there. If you're going to use this, you're going and use those 2 sets of IV tubing, it can get messy as you're moving things around. And a lot of these workbenches I go and I see, they are using towels to mop it up. And sometimes you even see somebody put a towel under the scale. The problem with putting these towels under the scale is, remember, the scales have to be perfectly level, and the towel adds some movement to it because you can compress it. It also adds just a moisture barrier underneath there and a place to collect bacteria and gross stuff. So you really don't want to have towels underneath it, but you're always mopping up these benches. And if I ever see you at a conference, ask me the story about demoing and somebody dumping an entire bag of fluid into my laptop because we were trying to move it to do the test with the IDA-6. There's 2 sets of IV tubing. If you're using it 2 sets, you're going to have 2 bags to do this, and it's another test setup. But I find a lot of hospitals, when they use those 2 bags, they decided that they feel that there's not enough of a variance in that calibrated test set, so they're just going to use 1 test set. They're not going to use the calibrated one. They're just going to grab one off the shelf. Some people say it's hard to get some of these test sets, so they just use a standard test set. Well, that adds yet more possibility of error. So when you add up that possibility of error, not using a normal test set, splashing water all over, having towels underneath your scale, that adds another variable. Did you catch the peak? That adds another variable. Did you dump everything out of your beaker? That adds another variable. Did you remember to push tare at the right time? That adds another variable. You end up with all these potentials of failure points. And that could be a real challenge for infusion pump testing, because now all of a sudden when you string those together, your tolerance is really wide. So that's why I like to push, or that's why I like to show the IDA-6. And then the IDA-6 is a little bit of a different story. Let me grab this bag here. This is the bag that I use for testing. You're going to notice it's much smaller. It's actually only a 250 milliliter bag. And the next thing you're going to notice about it is it's sealed. The reason it's sealed is because I don't have to refill this throughout the day. The IDA-6 has a neat technology into it. It has IntelliPump technology, which means when I turn this sideways, the fluid is going to come. You see we have two lines here. The fluid comes out of the bag, down the test tubing, through the infusion pump, into the front of the IDA-6. And it uses a piston-driven stepper motor inside. So as the fluid pushes the stepper motor back, once it's back, the pump pushes it back around, pushes the fluid back out and back into my bag. So I'm pretty much recycling this water the entire day. So I don't need to refill this bag. So when I first set it up in the morning, I just take a bag and I take a few syringes of fluid and I push them in there, set this up, run a priming cycle, and I can test all day on this, which also makes it pretty portable. But it's really nice because I don't have to worry about that mess. And I can just hang that up here like such. Which does make this portable, because what I've seen technicians do now that they're finding this IDA-6 is they'll set this right on the crash cart and they'll set a little IV pull on it with a little bag system, and now they can take this out to the patient floor. Not everybody likes to do that, but some people who have a lot of pumps see a big time savings versus having to go out and find those last few pumps, you know, the last 10 or 15% where you have to walk across the hospital and find them and drag them back to the biomed shop. Now you can take the IDA-6 right out to the pumps, test them on the floor, put them back in the floor, and you really get through those last ones without a lot of walking. So, now, if I was using the IDA-6, how would I do that? Well, this is a 2-channel IDA-6. How would I test? I'd go to channel 1. I'm hooked up to channel 1 right now. And I could either use the onboard automation, but if I'm using some of the infusion pumps that have to use their own calibration software, go to manual mode. And if I'm following the let's start with if I'm just using one set of tubing. If I'm that hospital that just uses one set of tubing, here I go. I would go to flow and volume. I would run my priming cycle, push play, run my flow test. And then I'd have my volume, my average flow, and my peak flow all right here on the screen. It'll pull them all up here on my screen for me. And it's high resolution. Remember when I showed you with the syringe? It's going to read to 1,000th of a milliliter or 1,000th of a gram, depending on which way you want to measure. And when I need to do my occlusion test, I would hit stop on this, push occlusion, and I could run my occlusion test right through this as well. Do the priming cycle, push play, and it catch my peak pressure for me. This is set up so that it will catch that peak pressure, and it'll mark it, and then I'll have my peak pressure, time to peak. If I needed it or wanted it, I could get the residual volume. So after it releases that the occlusion pressure, the volume that comes out afterwards. So this is really nice. This IDA-6 uses some algorithms in it for both the flow and occlusion, which catches the very start of the flow, as well as when there's that flow that drops off in that infusion pump test. It knows when it's done flowing versus when it's KVO, and will mark the end of it, which gives it this really high resolution 1% accuracy. So this is a really nice advantage. Now, for the technicians who really want to follow those manuals and use 2 sets, one for flow and one for occlusion, this is easy enough. I can use one bag here for flow, and then I take a second bag, another one of these little bags, set it up without my calibrated flow tubing set, run it down here and put it into channel 2, or in this case it's channel 4, but my second channel way over here. And I do 1 for flow, and I come over to 4 and hit this for occlusion. So I start my test. I set up, maybe if I think I have to do flow first. So I set this to, oh, this isn't a layers tubing set. Set this into the layers tubing. Start my pump. Run my channel 1. Run my flow through it. When I'm done with it, I take this tubing set out, take the tubing set for this one, go over here to channel 4, and run my occlusion. It really reduces those human error factors and the chances of making mistakes. Another great question. So the people who want to set up and run 2 pumps at a time, feature about this IDA-6 is I can simply flip this over, and I can take out these two blanks, and I can add two more channels to it. So if I started off with a 2-channel IDA-6, I can add two more and turn this into a 4-channel IDA-6. And in which case, maybe I choose channel 1 and channel 2 for one pump, and channel 3 and channel 4 for the second pump. And if I want to, I push this button, and I can view all 4 screens at once, or in this case, I only have 2, so I can view them both at a time and toggle back and forth real nice and easily. And again, this will catch the total flow, the total volume, and that peak pressure, and you do not have to be watching it. It's going to capture that for you, and even if you want to, it'll save it for you. So thank you very much for joining us as we talked about the IDA-6 and how it improves some of the human error factors of infusion pump testing, and we hope to see you in the next video.